Nico Carver, University of Delaware, tracking mouse movements to assess learning.
All right, hey everybody, thanks. So this is a direct sequel. I'm just gonna pick up where we left off 1 year later. And I have just as much to say, if not more, but half the time, so I fully expect to get gonged today. One thing that's I struggle with is I do a lot of one-off workshops, one-off classes, and by that I mean I have 2 hours with some students and then I'm never gonna see them again. And so that's a challenge on its own, but then how do you assess something like that? Traditional classroom assessments don't really work because those are mostly about knowledge, and knowledge takes time to develop. So for experiential learning, I felt we need experiential assessments. So that's why I developed something called MACAW, which stands for Mouse Analytics for Computer-Assisted Workshops. And the idea behind it is to have a whole audiovisual snapshot of what someone's doing on the computer. So you'd get screenshot data, you'll have mouse data, where their mouse is moving. I also audio tape all instruction so I can time things up and see what's going on in the workshop. When I presented last year, this was a prototype, and the award allowed me to do a pilot study. So I took my prototype, refined it, and did a pilot study, and I am glad to say today that the pilot study is complete. And so the rest of my 5 minutes, I'm going to be talking about what I did and what the initial findings were. So I had 36 participants. I attracted them through Amazon gift cards. They were all University of Delaware students. This may not seem like a lot, but that produced over 83,000 files of data. And so if you remember from last summer, this is what my data process looked like. I would look at the data and then try to make conclusions based on it. This doesn't really work when you have so much data. Also, what I wanted to do with this pilot study was look at the predictive validity of MACAW. So by that I mean, I have mouse activity here. You can turn that into a number and then compare that to another assessment to get predictive validity. So you can say, they transferred their learning, and this is how MACAW, the mouse movement, compares to another assessment and how they relate to each other. So I came up with some scripts to turn visual data into numbers. And this is all open source. And so you end up with some spreadsheets. It's all organized by timestamps, so it's easy to follow. But I'm more of a visual person, so the first thing that I usually do with spreadsheets is I chart them. This is 3 participants' mouse activity over a 2-hour workshop. And the cool thing about this is because I have those timestamps, because I have the audio instruction, I can break this down into learning objectives and see what's going on with mouse activity for each learning objective in the workshop. And then I compare that to a real skills assessment that I give at the end. So I ask them to use those learning objectives in a different context, then compare the amount of mouse activity to how they do on a skills assessment. And let me zoom in on here on one. So you can see right here that this blue line that represents one student, and something happens right there. They stop engaging with the computer. So what's going on? Well, with every learning objective, I start by modeling a new concept. So I'm up there, they can follow along if they want. I'm teaching them something new. And then I give them time to practice, to reiterate and really master whatever the subject is. And that blue line, that student decided, nope, I got it, I'm not gonna practice. So what I found was that if they didn't use the practice time, they didn't do well in the skills assessment. And this was true across my entire pool, across my entire pilot study. So this might not be groundbreaking for teachers out there, but what it showed to me was that MACAW does have this predictive validity. And if you're a statistics person, the correlation between those things, the practice time and the assessment, was 0.66, which is a strong correlation with a p-value of less than 0.001. So what I've done so far is taken this prototype, I've refined it a little bit, added the data analysis part. What's still not done is it's not easy. I don't expect anyone to be able to just take what I've done and dump it into their normal method of teaching and run with it. So that's what I'm doing next, is I'm trying to make it easy. last year I said when I'm all done, I'm gonna release it. Now I'm thinking I'm gonna release it as I go. So Figshare is a great data repository for all disciplines. So if you're interested in open data, go there.